And welcome back, guys. You can see already on the screen the next two presenters. Hey, this is Mike. I see his hands waving. Hi, Mike.
Hello, hello.
Hi, we can hear you well. And Oliver. Oliver Kracht. Hi, Oliver.
Hey.
Hi. So, yeah, just a few words before you go. Mike and Oliver are both chaos engineers from Deutsche Bahn. They're connecting from Germany at the moment. It's going to be their first talk in English, so please be kind. But I'm sure you will be. And you can ask all the questions, as always, in the chat. I'll be connecting at the end of their presentation, and we'll go through all of the questions that you have. So Oliver Kracht and Maik Figura, and they'll talk Clear the Ring for Chaos Engineering at Vertrieb Deutsche Bahn, 1 year sensations and attractions. I think they're going to talk about zoos, something with zoos and animals. So let's hear from them. So Oliver and Mike, take it away.
So thank you for the introduction. So chaos engineering at Deutsche Bahn. So I'd like to welcome you to our chaos engineering circus show. If you now think, whoa, wait, circus, what's circus? I was thinking this is about chaos engineering. So sit back and relax. I assure you are in the right talk. It's all about chaos engineering. We are talking today about chaos engineering. So why do we do that? So we do chaos engineering for over a year now in a quite large organization and want to share our experiences. So long story, of course, our IT systems are historically grown up to a point where we had to renew them. Reasons for that were maybe support was discontinued. We had a lot of brain drain. We had COBOL and other strange languages. And of course, the systems were not even cloud ready. So after that, we have a brand new maintainable platform and the possibility to roll out stable features and changes within hours, whether it's weeks or months. But all that comes, of course, at a cost. So now we have more teams, new technology, microservices, for example. So and new processes. And of course, the old monolithic world still plays a big part for now. So there were new challenges everywhere. In this talk, we focus on the implementation and operation of chaos engineering and how we integrate chaos engineering in our daily work, because that's a goal. On our chaos engineering journey, we took a lot of detours. We met errors and had burdens and hazards. So we talk about how to get on track again, and in the hope that you will not be caught by our mistakes. But what's that circus thing now? Well, we see some parallels between the organization and operation of a circus and how software development might be organized. So please let us know afterwards if you also see some analogies. Who's Deutsche Bahn? And what is or who is Deutsche Bahn Vertrieb? So let me give you some context. Deutsche Bahn is the biggest train operating group in Germany. And Deutsche Bahn Vertrieb is some sort of interface. So the interface between the customer and his train ticket. So basically, we sell train tickets. And for that reason, we develop software systems to support that. Customers can buy tickets over multiple channels. So there are vending machines, mobile applications, online, and of course, in person. When there's no pandemic, we sell a couple of million tickets per day. So now you are knowing what we are doing. So let's look at the topics today. So how the show evolved, the roots of our historical systems, and what kind of systems we have now. Second one is chaos engineering to tame them all. We try to discuss the point if chaos engineering is some sort of magic wand which turns every system in a super robust, resilient platform. Well, fire drills are part of chaos engineering. We are talking about how fire drills are practiced and why they are not practiced in the development. So we call a fire drill in the context of chaos engineering a game day. Later on, we explain the concepts behind game days and other chaos engineering practices. Yes, and now the excuses. There is always a reason not to do things. You know that. Here we talk about the most frequent and absurdly excuses and how we react on them. And last but not least, our top 5 lessons learned. So the most painful experiences while rolling out chaos engineering at Deutsche Bahn Vertrieb. So, but what is chaos engineering about? Principlesofchaos.org stated that chaos engineering makes my system capable to withstand turbulent conditions in production. That's great. Everyone wants that. Why don't do everybody chaos engineering then? So that's a good question. What I know is the value that chaos engineering gives to us. So it helps us to discover unknown technical debt. So the debt that we were not aware of yet. It helps us proving and verifying non-functional arguments. So architectures like that. So, and one very major thing is it lowers time to recovery and increases the time between failure. Also for proving the success of chaos engineering, measure these metrics from the beginning. And finally, by adoption of chaos engineering, we gain more resilience and robustness. And as well as, of course, a better understanding of the processes in case of failure. So that's about chaos engineering. Now, let's have a look at the actors now. Welcome to the show. So these were the good old times, the monolithic age. The show was well known and no surprises for the audience. This show was very predictive. So why? So we only had 1 or 2 tents painted in blue from the outside, and signs stated, yeah, some sort of web sphere. This was very sturdy and durable the last decades. Yes, but the surrounding parts of the system were much older and programmed in languages which I either haven't heard of or treated the name more like a fairy tale. So with this setup, we could not fulfill the demand of the new audience. Yeah, because it took a long time to establish a new show or introduce a new act, sometimes more than 3 months. So today the audience requests a 24/7 show, even in multiple tens or parallel shows at all. But one part of our organization loves this show. So that's operations. Because it's very stable and known, so there were no surprises, good to operate. So in contrast to business and developers, they want change. They want new features delivered to the show. And of course, at a modern cadence. So business has money. So this is how our show looks like today. There's much more going on here. So we have more tents, 24/7 shows, even multiple of them in parallel. And the best of all is, shows are updated while they're running. What have we done to support that? What have you do to come to such a show? Change the delivery process. So we moved to a cloud-ready technology stack. We scaled up the number of teams. We use some sort of domain-driven aspects to separate the concerns. So we do everything to enable us to get started with continuous deployment. And that enabled us to change the show while it is running. Our quality assurance also had a mind change. They went from manual testing procedures to fully automatic tested. And also new processes were set up to support these changes. So we have new incident processes and operating procedures. So that's a lot. So having a so powerful CI/CD canon, which allows you to shoot features directly to production systems. Imagine what could happen if you change the actors jiggling to chainsaws within a Git commit. So what could possibly go wrong? But I tell you, this is the first feature we released on our new platform called KCI, also known as Comfort Check-in. It allows you to check in at a seat in a train, and you will not be bothered by the conductor asking for your ticket. So that's great. Now you have quality time while you're traveling by train. So have a nap. Yeah, this was the first feature which connects new platform and the current old monolith. Yeah, guess what happened? Friday, 5 p.m. Everybody's waiting for his weekend beer. The new features went silently down. So customers start far away. So what happened? No time for analysis now. Just restart the service and keep fingers crossed. Pooh. Services start working again. But yeah, this error had side effects and was not only affecting KCI. We encountered a cascading error here. This was serious, as the customers could no more download their already bought tickets. So imagine you paid and don't get any ticket. So this was a serious problem, a bad thing. At Friday, 5 p.m., people want to get home by train. So as a result, of course, more complaints, more headlines about the issues in our big newspapers' websites. So this time we didn't make it to primetime news. The only reason for that was that our incident managers did a great job coordinating the fixes of the issues. But there were uncomfortable questions asked. Concerns regarding our new platform were expressed. And from all directions, the most important question was asked. Oh, what is the most important question after an outage? I bet you know what the question is. Yes, who is responsible? Who is the guilty guy? So a big postmortem revealed it very efficiently. So job done. But maybe we asked the wrong question, because only knowing who's responsible will not prevent us from further or future outages. It's more about asking, why did we fail, instead of who is responsible. Yes, we had to learn that, asking the right questions. But we had a quick fix. We have added the adjective blameless in front of postmortem. Now we have blameless postmortems. Yes, continuous improvement is starting. Great. Remember, we had changed everything, technology-wise, our culture, our responsibilities, and the process. In addition, we have this monolithic system which is still running and which is operated completely different. So maybe we have to change something. So that's what we all agreed on. But there's so many things you can change. Maik will tell you about some of the ideas we came up with.
Yes, thank you. So we put our heads together, and as you can guess, every department had some sort of idea. One department was asking for more governance, the other one was asking for more tracking, and so on. And well, in the end, we asked ourselves, do we really need more of something to bridge that gap and the problems we have? Because we guess that won't help to reach our goals, which were to get faster with less errors, better UX, basically making the customers happier, right? By delivering features faster. But, well, we still introduced some sort of new test. And what you have to know is in our organization, we have a gap. So we have two departments, ops and dev, and they don't talk to each other. In fact, they are different companies sometimes. So the idea of those tests were pretty simple. Right before going into production, these tests will make sure that the deployed services work. And you can guess ops had a big interest in these tests because they have to take care of it on the weekends. But please keep that slide in mind. I will come back to that story later on. For now, you just have to know that we introduced another kind of test. And you can guess, well, that didn't really work out either. So this time we thought, what would Netflix do? That's what every good company asks themselves nowadays. And I guess that sounds mad, but let's have a look at it. I mean, we do have less microservices, but we still have them. So the complexity is probably not too different in taking care of the services and in deploying them. Why Netflix? Well, because compared to on-prem, Netflix noticed that different things are important with microservices in the cloud. And Netflix introduced us to all the chaos engineering practices and methods to mitigate those problems. And overall, for them at least, it led to a higher stability of the whole system. And I mean, who doesn't want higher stability in the whole system, right? So, well, we're not Netflix. I take that. But if you look at this, this is an actual screenshot from our system. And each of these dots is a team or several teams. And you can guess it's kind of not the Death Star you maybe know from other presentations, but the problems look the same. We have a complex technical system. And what you can't see here is there is also a complex social system behind this, with many teams with different responsibilities and slightly different approaches, a different culture, or different experiences. And even though we decided to have guidelines for all the teams, like you have to build in resilience, you know, how would you even test that? Right? It's hard. So we thought, well, there must be something we can do, and there is. There is the Chaos Monkey. So on the shoulders of giants, we asked operations whether we could just deploy the Chaos Monkey for Kubernetes, and they agreed. Yeah. So we put the monkeys to good use and fired. And how that went, Ollie will tell you.
So without knowing much, we deployed the Chaos Monkey. He did a great job. Killed pods and containers in one of our gazillion environments. Yes. But to be honest, we didn't really know what we are doing. So a fool with a tool is still a fool. And so you can guess how that worked out. It ended in tears once again, because the servers were not prepared and we were started too big. But what do you guess was the worst? The worst was nobody noticed. We didn't have the observability to even detect the errors. So we were not prepared. We didn't do our homework. We did not communicate enough. We didn't have the needed observability. Without much of a plan, we did dangerous things. We felt like chaos engineering was won the first initiative of the year award. Yeah, this was really bad. There was only one last chance. Do our homework and start over at the drawing board. We didn't think, plan or experiment, we just deployed. So Ross Miles said that chaos engineering is a thoughtful, planned experiments about and socio-technical system to reveal weaknesses before you get catched by them in production. So we started over with chaos engineering. All these monkeys and warthogs need accommodation. So we need new cages for them. So get a bunch of consultants to develop Excel-based meal and training plans. Specialized trainers needed. And get all departments at the round table and design a process that, when it's printed out, hardly fits on the walls of a meeting room. And what costs nothing is no good. So open the treasure chest and spend some money.
Wait. Stop. I don't think you need any of that, to be honest. Well, what you definitely need is you just need to start doing chaos engineering. And what do we mean by that? First, you pick an aspect of your system you want to experiment on. Then you plan your experiment. Prepare your environments, especially traffic monitoring access rights. Measure the steady state or the baseline. Then monitor your systems right before that. And then, only then comes the conduct the experiment part where you actually are allowed to break something. So you see there are many other steps where you don't need a big budget or whatever. You just need to get your developers a little bit of time to do that. And then you document your findings so they can be shared with other teams, right? What does it look like? Well, this is a photo from an actual game day, one of the earlier ones. But what you can see is you see ops there, architecture, Ollie and me, another dev colleague, business ops, and the developer in the background. And it's kind of like a war room, but we don't call it war room, we call it game day. And it pretty much brings together all the people, all the right people at the same time in the same room, in the same thought space, right? So, and this is kind of the point where I tell you about where I tell you about our first game day with the slide from the beginning with the different departments. So on our first game day, we put together a team with 10 people or so, and there were developers with more than 20 years experience. And before the game day, we asked them whether they think if we find any problems, and they all agreed that we will not find anything. So what we did was simply we combined the two tests, which I showed you before. We did performance testing and a rolling update while we had a real production load on the systems. And guess what? It almost ended in tears. The error rate spiked up to 100% for 50 minutes. And to be honest, the services didn't even recover themselves. So it was kind of depressing for all of us. We expected some errors, but not a complete failure on broken services. But on the bright side, I mean, that was quite a wake-up call for everyone. And on a side note, after that, we never had any problems to get the buy-in from management. And for us, this is kind of the value of chaos engineering, because it increases cross-team communication to reduce the friction. And I guess the two teams could have avoided that mistake by talking to each other, but they never thought they have to. So this is one big plus for us. The next one is you can verify your non-functional requirements. And by that, we mean that you can find unknown technical debt. Ollie already said it, it's the unknown technical debt that your users will find in production on a Saturday night when you want to open your first drink, which is normally pretty bad. And on a side note, it does reduce the time to recovery because people get used to stressful situations. They know what to do. They will react in the right ways and they will fix your system faster. And on the other hand, because you will have all those findings, it increases the time between failures, because you will be able to mitigate many of those findings with circuit breaking and other resilience patterns. And I was lying a little bit earlier on that you don't need tooling. A little bit of tooling is needed, but not that much. The most important one, which we want to point out, is you have to invest in a great application performance monitoring solution, like Instana or Dynatrace or whatever. But it needs to be something your developers and your teams are actually comfortable to use and that they actually like it. So also, in the beginning, we mostly used Pumbaa and the Chaos Monkey for Spring Boot. So we didn't really think about all the automation you could do. Pumbaa is the tool to manipulate the Docker daemon, and the Chaos Monkey for Spring Boot, well, we are a Java company, so this is kind of nice. But to be honest, much more we weren't comfortable in using. So we started really small, and that really helped us. And only now, after like 80 game days or so, we are evaluating a chaos engineering platform like steadily or Gremlin or whatever. And to be honest, if you really need tooling, there is a really awesome GitHub page where you can find all the tooling updated, also great open source tools. So we now have all the protective gear in place, I guess, right? So everybody's informed and everybody's there. But to be honest, we still had problems to get started. And some of those problems and excuses Ollie will tell you about.
Well, yes. So we come to know our top 5 excuses not to start with chaos engineering. On number 5. So go live is in a few days. You are messing up the test plan. So we are having crunch time now, and please do chaos engineering before the next release. So, well, what is he talking about in releases? So we don't have releases, we have continuous deployment. So what's it all about? No. Just kidding. So integrate chaos engineering if you have a test plan into this test plan. Or even better, shift left and integrate chaos engineering into your daily development process. So in any case, keep talking and make QA a really friend. Convince them that chaos engineering may have experiments which can result in real tests in the future. So this is a win-win situation. So you can work together at this time. Number 4, we don't have enough access rights. So often this actually means that there is a technical gap. People often do not know where to find the information they are searching for. So indicating questions are, for example, oh, we cannot access the logs in the monitoring. So, or our development database is only accessible by operations. So we can't do anything. So, and as a chaos engineering, if you ask, so did you even try this? So often these problems disappear when talking and discussing with operations or the correct stakeholders. So you have to work there. So this is a good one. Number 3, we can't think of any good experiments that are useful to us. Whoa, do you know your services? So this should ring the alarm bells. Your effort in implementing and operating chaos engineering was not enough here. You have to find the reasons. Maybe they are just ignorant to chaos engineering, or they really don't know what chaos engineering is about. Give them more coaching and explain the gains from adopting chaos engineering in their development process. Try to push the experiments to reflect real use cases instead of only thinking on technical aspects. So give them other formats of game days. Maybe they don't like the format you promote at the moment. So yesterday there was a talk about chaos engineering, which shows very good chaos engineering game day formats. So check this out. And also give them standard experiments so they can derive their own experiments. Number 2, there's no time because right now we are doing features. So these technical things we do later on. So this should ring the alarm bells again. So use cases, technical and non-functional requirements are inherently connected. And the devs might be forced to make this decision sometimes. So in this, everybody knows what will happen when you accumulate too many technical debt. Yeah, it gets poisoned in the backlog and will eventually be ignored until they hit you in production. This approach is very, very risky. So there are many reasons for that. We often see that some product owner is more like a backlog manager than a person who feels responsible for the whole product lifecycle. So be aware of this. Number 1, yeah, we would love to do chaos engineering, but the product owner is not prioritizing it. You remember the last argument about the job of a product owner? Well, yes, that's because the product owner might have opposing aims and is measured by the cadence or count of delivered features. And what's really sad about is the product stability suffers with this approach enormously. And often this is pushed by management, but that's another story. How to mitigate this? Yes. Remove her possible fear and uncertainty and stress out the value of chaos engineering for the product itself. So for example, show them the value of chaos engineering by doing at least one game day, which has a small scope and maybe a great outcome. In addition, so recruit operations and security as a driving lever or force. So they have other ideas. But regardless of the excuses, we did manage to host some game days and do chaos engineering. So 80 plus game days up to date. So many findings and weaknesses discovered, which will hit us no more in production, and our first games in production were made. So we gained enough trust to host the first game days in production. So, and we are very proud of the fact that multiple teams doing chaos engineering on their own. So they host their own game days. So that's great. They adopted and like that. So different game day formats I talked about earlier. So red teaming, Wheel of Misfortune, or playing the incident process. That's all about chaos engineering. And very useful to us for an entry place, for an entry in chaos engineering is having a place where all the documentation and experiments will be collected and accessible by everyone. This helps teams to get ideas for new experiments, as well as the possibility to share their findings, because problems are often the same. So if you have 100 microservice based on Spring Boot, it's quietly possible that configuring health checks or DNS or rolling updates might be equal. Yeah, build up our community. Promote the finding of the month. Just having a place where teams can talk about chaos engineering and share their experiences is great to have. So write blog articles, record podcasts, whatever you want. So this all helps make chaos engineering more visible and maybe become a success. So Mike's going to talk about our top 5 learnings now.
Yeah, let's wrap that up. So after over 1 year of chaos engineering, well, it took us quite a while, but now we know. People, processes, and practices are the key factors. So what this means is you have to talk. Communicate with your stakeholders, get them together in game days to test the system and learn about it. It's not so much about the technical stuff that can be managed, but people are complicated and they have to talk to each other. So if they don't do that yet, you have to get them there. Number 4, don't just deploy the chaos monkey like we did. If you don't know what you're doing, this could be really harmful. So, and tooling, to be honest, is the least of your problems. Start with a pretty simple game day, with an easy experiment, and then share your findings with other teams so they can learn from them too. This is kind of the biggest value. It took us half a year till we even thought about automating some of our experiments. So, and this was around 50 game days or so. And if you're a developer, you probably know a very good principle behind this, because pre-major optimization is the rule of all evil. So keep that in mind. Number 3. Well, yesterday someone asked why you shouldn't start in the production with chaos engineering in the other talk. Here is the answer. Start small to gain confidence so you don't harm anybody. Because if production is down for, let's say, half a day or something because you did some chaos engineering there, well, your company could be in jeopardy. So yeah, start small to gain confidence and start in development, testing, or staging environments. But aim for production, right? So if you're confident with an experiment and it works on the development, testing, or staging environment, then do it in production, because this is where the real fun starts. Number 2, well, don't be afraid to bug people. Don't get discouraged. This is also like taking the plunge. There are always jobs that nobody wants to do. And so in the first game days, we did moderate them, took care of the documentation, and we tried to make it as easy as possible for the participants so they can focus on the actual learnings, findings, and experiments. What really helped us was to get allies like ops, but it's a long way and you have to stay positive. And number 1, at least in bigger companies, this is always a fun thing here. Don't get eaten by the process line. What does that mean? Well, other departments want a piece of the cake as soon as chaos engineering is successful. At least that's what happens to us. So In our case, quality assurance wanted to make specific experiments mandatory. So they asked us whether we could always do them in game days, kind of like making their checklist green. And we think this is bad because game day experiments should be self-driven by the participating teams because they know best what they need and they have to take care of it in the end. So this is also why we came to hate checklists, because most of the time they're pretty useless. Often there are better alternatives and you have to present them. And well, also there are no excuses. I mean, we are a big company, but we still do chaos engineering. Maybe a bit different than Netflix, maybe a bit different than a small company, but we still do it. And this is kind of the thing we want to give you on the way, because we want you to do something. And that something is invite your team to your first game day. Share your findings with other teams and, well, go out and do chaos engineering, basically. You have to fail once or twice to know how to do chaos engineering. Thank you.
Thank you. Yes.
Yeah. Oh, okay. So thank you, guys. Thanks for a great presentation. Thank you for explaining it all through a perspective of a zoo. I think that helped a lot. And as a first English presentation, I said there was nothing to worry about for you about. So it was great. And we have a few questions that I want to ask out loud. So Almantas Karpavičius, he was the first one to ask. Thank you, Almantas, for putting your question again. I said it in the first time, but that's great from you. So the question is, how early in product development lifecycle should chaos engineering be introduced? Would you suggest chaos engineering to be used only for solutions with big streams or requests responses?
Ollie.
Thank you, Maik. let me answer this question. Yes. So as soon as you are moving to an environment where some services are interacting with each other, it makes sense to introduce chaos engineering at this point, because you get used to the procedures and the techniques and the tooling, so you can just have your first experiments on this new feature. So maybe this answers the question a bit. But if you want to know more, so we are in the chat room afterwards, of course.
Okay.
Maybe to add something to that, there was also the question whether it should be used only for big solutions and streams. Well, at some point you will notice that you need to focus on use cases, and I guess there are not a million of them. There are important ones which need to be there all the time, which need to be resilient, and there are other ones that don't need resilience. And I would focus to learn the practice on smaller ones, and at some point you switch over to the more important ones, which will also help you to be really resilient and make your customers happy. Great.
So Almantas is saying thank you. So I think you answered his question quite to the point. If anyone has any more questions, you can still write. I want to read. Evaldas Slushnis had a question. So it sounds like this: What is key differences from chaos engineering and automatic testing in CI/CD pipelines? Does chaos engineering tests could be? I'm sorry, that was a mistake. Maybe does chaos engineering tests could be later automated? Did you have such cases? Can chaos engineering tests be automated? Yeah.
Well, it's probably me, I guess, Ollie, right?
Yes.
Yeah, I do that.
Silently.
Well, in an experiment, you pretty much, well, you hope for the outcome, but you're not really sure about it. You hypothesize about it. In a test, the scope and the outcome are 100% clear. And this is, for me at least, this is the key difference. I know that some people say chaos testing and others say chaos experiments. Well, basically, I don't care, to be honest. But for me, as soon as the scope is 100% clear and we know an exact outcome which we want to have, then it's a test. And if it's an important use case, at some point you need to automate it. And you can do that with CI/CD pipelines depending on your environment. Yeah. So, and we did have such cases. For example, the one we showed, the rolling update with production load. This is one that has to work. There is no discussion about that. We want zero downtime deployments, and if that doesn't work, you can't go to production pretty much. So we test that earlier with load generators.
So there's a transformation from the experiment. So later on, this can be a test, of course, but to be free to experiment, and you have to define this hypothesis. And yes, it's more about a room where you can think out of the box, and maybe later on these thoughts will end in a test which you run in a CI/CD pipeline, of course.